Hey. I think the stream lag means that when I click go live, it, it catches the couple of seconds where my head was down on my phone. Love it. Good opening frame. So I've put a couple of things in the chat, some intro things. If y'all see that, let me know. And if the chat is just empty because I typed it before the stream started, let me know that as well. But welcome to 2021, everybody. We made it. 2020 is over. And with this stream, I'm going to just step through some of the stuff that we put together at the end of the last year. We released a couple of things that are worth sharing. Hopefully this will be new to you. Hey, Ilya, good to see you. Ilya, can you let me know if the chat has my intro, hello, and everything like that? And if it doesn't, I'll send it again. But yeah, so I'm going to kind of step through some of the new website stuff. I'm going to step through some of the new Hype command line stuff, and then I'm going to jump into developing a really simple node application using the stack. Hey, Ryan, good to see you. And the good news is for y'all that, okay, great. Good news is that I took the Christmas and New Year's vacation completely off for maybe the first time in my life. I didn't touch code or anything, which means that I barely remember how our hyperstack works. So I'm going to be stepping through this step by step and learning along with you by rereading the docs I wrote. It's funny how that is when you take a break. Man, that stuff just flies out of your brain. So let's start with new website. Hey, new website. We launched this thing right at the end of the year. And hopefully it is going to help people get a good grip on what the heck is going on with the stack. We now have all the documentation put together, lots of examples and guides, and a little bit explaining why you should care about this thing in the first place. Got to do your marketing. As always, I'm going to plug our Patreon real quick. Got to do that. So if you're into our stuff, want to help support us, some folks are already contributing to the Beaker Open Collective. Thank you very much. I appreciate it. But we have a Patreon now that we're kind of making more about the Hypercore stuff. So join that. We would much appreciate it. So website here, we got, first of all, of course, a simple simple bit of instructions to install the Hype command line and get started. But the most important bit, I would say, is the guides. And we went pretty all out on this thing, putting together guides for getting started with the Hype stack inside of Node.js applications. So this is like if you're not building in Beaker, but you're building from Node.js, any kind of application, we now have the guides for you. And there's really two different ways to use Hypercore right now. One of them is with the Hyperspace daemon, which is kind of a nice batteries included tool set for building things, or if you want to use the standalone modules. Generally speaking, I recommend always using the Hyperspace daemon unless you have some really specific use case. And so that's what I'm going to be doing today is I'm going to be building off of the daemon. And so we're more or less going to be stepping through this part of the guide for setting up an application and talking to the daemon. Then I'm going to make just a really simple web app that lets you browse around inside of a hyperdrive. We also have a lot of good documentation on the new Hype CLI, and so I'm going to start by showing a little bit of that action. So let's open up my iTerm here. So the Hype CLI is something that we've been needing to get done for a while, and really glad we finally have it done. Let me make sure I got the most recent version installed globally. So do npm install global hyperspace/CLI. Hey Mario, good to see you. What does Beaker use? Which stack? So Beaker uses the same stack, but underneath it's the same stack. But Beaker kind of presents a different version of all the APIs that's geared towards the web environment. As a result, it can be a little bit more constrained. Whereas with the node thing, because the environment is so different, you're actually sort of more free to access all the little pieces of the stack. And in many ways, that could be pretty handy. So just depends on what you're doing and what you're looking to have. So here it is, the hype command line. We've got a ton of commands in this thing, and it's probably only going to grow. This thing will probably get bloated, and it's going to be a fight to avoid that. But I have, let's see, some data sets here that I'm seeding. And so the nice thing about the hype command line is it spawns the hyperspace daemon in the background and keeps all your stuff online. So even though I don't have any kind of GUI application running, I got this thing here seeding for me. And it looks like that, if I remember correctly, this one is my personal hyperdrive. And I am going to run the ls command to just list all the files inside of it. And yep, definitely is. And so we have a couple of nice, shortcut commands for dumping information out of hyperdrives. For instance, if I cat readme.md, there it is, right? And there's a whole set of useful commands here. You got ls, make a directory, remove a directory, cat to just, output the contents of a file, put to write a file, rm to delete. Diff is a really useful one, actually. This one we haven't talked about nearly as much as I feel like we ought to. I'm going to diff my drive against just a random folder here. Think of a folder I can diff against. It's not going to be private information. I'm going to mkdir temp foo already exists. All right, and I'm just going to echo hello into temp bar test.txt, so it has something in there. Okay, so again, the diff command, it's kind of, it's just a file tree diffing tool. So I'm going to do hype diff and then my personal drive and then temp bar. And it lists exactly all of the differences from the left item to the right item. And I got a lot of stuff in here, so maybe I can find a better drive to be futzing with. Let's see what I got. Probably one of the latter ones is just a... No, not that one. Not that one. Looks like those are other people's personal drives. How about... In fact, all of these have enough seeders that make me think that they're all people's personal drives. So you know what I'm going to do is I'm going to create a drive. So I'm going to do, it's actually hype create drive. Okay, new drive created. And if I do hype info, it should be showing in my list of seeded items right there. I'm going to grab that URL and let's diff that. So hype diff the key and then temp bar. Now what that's doing is it's diffing from the left argument to the right argument, right? And the idea being that if I were to say sync the two from the left to the right, here are the changes that would occur. And so in this case, temp bar has a single file in it and my hyperdrive is empty. And so if I were to do a sync to that target, it would actually delete the test.txt, right? So let's reverse the argument order there. Temp bar and then the drive, right? So now it's going to be diffing from the left being the folder in my hard drive and the right being my hyperdrive. And now it would be, okay, you would be adding it. And so from here, the diff command has a switch you can pass in, which is commit, which would actually cause that difference to be, synced over, which is also another command called hype sync, does the exact same thing. It's the same code. It just doesn't include the, the diffing step. So if I do now hype diff from the left being my local folder and the right being my drive, which is empty, and then -C, it'll give me a chance to review what's about to happen. I'll say yes, and just like that, my drive now has the test.txt inside of it. Oop. No such file. There we go. And just for fun, let's do a quick put. Echo another file. And I'm going to do hype put into my key, and then we'll do this as test2.txt. And now I've just written a file into the hyperdrive. ls again. There it is. And now if I do that diff again, right, test.2.txt is not in the temp bar folder. So if I reverse the order, now I can sync back into the temp bar. So now I'm saying from the hyperdrive to /temp/bar, and I'm going to commit that, and now test2.txt will be in the temp bar folder. So handy little tools for interacting with hyperdrives on the command line. Pretty straightforward stuff. The sync command is probably a little bit, this is kind of what we consider to be one of the more common ones that you would be using, you know, in your workflows. And the kind of really interesting thing you can do is the live sync. So I'm going to do the same command going from the, you can do it in either direction, same as before. I'm going to do syncing from my local file system into the drive. And I'm going to turn on watch mode or live mode. I'm going to begin the sync going from temp bar to the hyperdrive. And there it goes. And now I'm going to open up a new prompt here, go to temp bar, and I'm going to echo yet another file into test3.txt. And it happened so fast, didn't even see it there. But if I ls into my drive now, ls, there it is, test3. So now I got live syncing. So lots of useful commands. One other thing that we added in after making the hype command, I forget how this happened, but at one point I just sort of offhand said to Matthias, you know what would be cool is if we did a magic wormhole. Magic wormhole is an existing tool that exists. It's a cool idea. Basically, it is a way to send information from one device to another. It works by creating a sort of a temporary, like time-locked passphrase. And I'll demonstrate it now. It's called Hyperbeam is what we called our thing. So if I call it, it's going to generate a passphrase for you like that. Wait, go, review, right? And we may need to lengthen that passphrase. We're still kind of figuring out exactly how this should work. But the way that ours works is that it becomes basically a stdio stream point. So if I echo, this will get hyperbeam into hypebeam. So what we have effectively done is created like a networked pipe. And on any other device, if somebody out there is faster than me, hopefully not, they'd be able to grab it. I'm going to, on my other terminal here, run hypebeam and then the phrase plain mind test. And it will use the connectivity layer to find the device hosting off of that. Now, hopefully this thing is going to work for my demo here. You never know. But what should happen, oh, you know what? I think I may need to put it in quotes. Let's find out. Classic demo gods. Huh, I wonder why that's failing. Maybe that I just can't discover myself. But I swear I've tried this before. Well, this is the idea anyway. If this thing were to work correctly, it would basically cause the phrase that I echoed into hypebeam here to cat out over here into the stdio. And I'll have to look into why, a little side note for myself, why doing it on my own device is not working correctly, because we've tried this multiple times, and it was working before the break. Let's make sure my usage is right. Yeah, my usage is right. Okay. Well, we'll have to look into that one. Did I get the plain mind? Oh, I misspelled the phrase. Plain mind test. There it goes. that's an important step in the old Hyperbeam. You have to get the passphrase right. Plain mind test. There it goes. And you can see there, the output got hyperbeamed. And the one that I was sending it from, terminates after that happens. So it basically kind of keeps that command active until the other side is able to receive the information, and then it ends itself. So it's a one-time use kind of passphrase. Ryan says it's like a stream, exactly like a stream. It's like a networked pipe. You can do pretty cool stuff with it. Like I'm gonna go to temp bar, and so I can cat a file, and then at the other side I can do Hyperbeam idea active hearing. That's my passphrase, and then write it out to another file, and just like that, boom. File transferred. So that is effectively the most bizarre stack for a copy command ever created when you do it only on your local device. Okay, got a question here. So what happens to Beaker? Does Hyperlink just add an extension to make Beaker better? So the HyperStack integration in Beaker, it's demonstrating how you can have peer-to-peer websites inside the web stack. And we're sort of trying to figure out what to do next with Beaker, to be honest. In the last year, we spent a lot of time, and I talked about this a lot, building a pretty complete social application using the Hypercore network. And a lot of how it was built was a lot of kludges that we were trying to get around the fact that the Hypercore Protocol, it's still a novel technology, it's still in development, and it lacks some pretty key capabilities. And the most unfortunate capability it's missing is multi-writer. And so we were trying to kind of work around some of the limitations of the technology, which, this is getting worked on. We have a team that's actively working on things like multi-writer now. But just wasn't ready, and so we were building applications, web applications, using the P2P stack, and it was just kind of like not really panning out that well, to be honest. It was we built the entire kind of peer-to-peer Twitter clone, and it worked, but it was a lot of kludges. The tech felt a little bit difficult to use, and we weren't super psyched about shipping it. So while you can totally make a peer-to-peer Twitter using the HyperStack as it exists right now, we felt like it wasn't a winner, So we decided to kind of press the pause button and make Beaker just the most simple thing it can be, which is peer-to-peer websites. And then let it sit while we go back and fix some of the kind of core pieces of the Hypercore stack to make sure that all of that is working as well as possible, so that whenever the time comes that people want to make more advanced applications and kind of take the second-order steps with the technology in an environment like Beaker, it's not bad tech. We just wanted to be proud of the product. And so this is why we then sort of, after releasing Beaker, stepped back and started working on things like the Hype command line to make sure that all the tooling in the ecosystem is in a good place and that we're actually doing something that's valuable to people as quickly as possible, such as making it as easy as ever to send files between devices, which is like where the Hyperbeam stuff comes into play. So I don't know if that answered your question. I'm going to try to say your name, Arena. But feel free to ask more questions about it. Ryan asks, what about something that would stay open? Like a tail on a log or something? I don't know. I've tried it. Let me think. I suspect it would work. What could I tail that would give me that kind of output that I could demo? It wouldn't be giving something I don't want to share. Yeah, I don't know. If somebody can think of something I can tail that would be sort of safe to put on the stream, let me know, and I'll try it out. But I haven't tried that yet, so I think it would work. I think the way that it's designed is, I don't know how the back pressure would play out, to be honest, because if you had something generating, if you had a stream going into the Hyperbeam that's dumping data in, it's buffering that information until the connection is established, and then it's going to send it all. So I wonder if you would possibly run into a memory overflow while waiting for the Hyperbeam to get connected. Anyway, I haven't tried it, so I'm not sure, but that would be a cool feature to have. Just haven't tried it out myself. So anyway, the Hyperbeam stack is interesting. We're talking about maybe continuing down that route as a we're today had a big call saying figuring out our next priorities. But one of the things that we're thinking about is, okay, what more could we do with this Hyperbeam idea? Because it's pretty useful for pairing devices together. So we'll see what's next on that front. So, okay, that's the situation with the Hype command line. There's also some tools for working with Hyper-Bs, which is a different kind of data structure I'm not going to get into today, but also have Hyper-B commands there as well. Ilya asks, you could just do a file. I guess I could. I don't know. Yeah, if I tail the file, now all right, test4.txt, and then this is testing my, so if I, is it -f? Yeah, okay, so let's, first of all, tail-f test4, and then let's see what happens when I've never actually futzed with this. Yeah, so I don't know if it may have to be opened in a pin mode for that tail to actually correctly. Oh, I guess I could do this. I could do echo. All right, so I could do echo more and then use the. Okay, so that works. Okay, let's test this out. So now I've got a tail that is correctly. I have a way to tail the file live, and I can append to the file using the command line. So let's see what happens when I pipe tail into Hyperbeam. Okay, and now I'm going to open up a Hyperbeam on the other end for listen even constantly. Okay, so far so good. And now I'm gonna, it does work! Yeah, looks like you can actually do live piping. That's funny. Yeah. Like I said, if you had a bunch, I mean, it's going to be buffering whatever input has come until the network connection is established. So I don't know how great of an idea it is. You might end up with the memory running out, which isn't a big deal. It'll just crash out emim, whatever. But there you go. You can do it. That's pretty cool. Okay, Arena says, at least I can understand why you're moving to Hypercore. I do think you're... I appreciate it, Arena. One step at a time. I'm actually really happy that we're shifting focus to the core of the stack more because I think the end result will be a much more solid tool set that, and this will also help us kind of handle some of the things that we were sort of missing over the years because we were so focused on trying to get to being able to build web apps inside of Beaker, and we didn't spend time on just fixing some of the simple problems like having a good command line tool set. Okay, so that is that. So that's the Hyper command line. Other things just to plug the website, since we put in the work, might as well make sure everybody knows we got documentation that shows how the stack all fits together here. Why don't I step through this in half a second? We have walkthroughs for using different pieces of the stack. So if you're thinking about getting started with something, we got nice little walkthroughs for using Hypercores, Hyperdrives, or Hyper-Bs, and I'll explain in a moment what those are. We have this great workshop that Matthias and Andrew put together that actually steps through how all the data structures in Hyper works, and I found it to be surprisingly approachable. They really did a great job with it, and probably going to be turning that into a talk for FOSDEM. So a great little workshop there. Got an FAQ for any kind of questions you got. Hey Wes, good to see you. Wes, Todd, and I used to work together at White Lion, a dev shop in town. Good to see you. Okay, so let's talk about the module stack here. This is a pretty good high-level overview of what all is inside of the Hyper stack. And the way to read this chart is you've got these two modules right here, Hyperdrive and Hyper-B, and they kind of live on top of the core stack, right? And then the core stack right here, you have Hyperspace, which is the daemon. That's kind of batteries included, got everything handy for you. And then what Hyperspace wraps are these three modules right here. So whenever you're getting started and you're trying to decide if you're going to be using the Hyperspace daemon or using the standalone modules, that's the decision you're choosing between, is whether or not you're going to be using all of them put together nicely or the individual modules that the Hyperspace wraps. 4 months, it's a good streak. Let's talk about each of these modules. Starting from the top, Hyperdrive is a files archive, kind of like a Git repo almost, but it's peer-to-peer, exists on top of the stack. Hyper-B is a key value database, kind of like LevelDB, really similar to use. In fact, if you look at the API here, this should look super familiar. And then here's the Hyperdrive API, which looks kind of like the Node.js FS module. Could we get an updated Beaker on FlatHub? I don't know. Linux is really hosed right now. I'm struggling to figure out how to fix Linux because I don't want to move away from what I'm trying to talk about too much, but the Linux build is kind of foobar, and it's because of a problem with Electron. So I'm going to say, hopefully at some point, we will get that done. But then also, like, the Flatpak format is kind of foobar too. It's kind of a mess. So I'm sorry, I'm going to say it's not going to happen in the near future. You're going to have to build from source still. That's the only way to make Beaker work in Linux right now. Okay, back to what I was talking about. So we got Hyperdrive and Hyper-B. Those are our top-level data structures. Those are usually the things you're going to be building off of. And then the lower-level stuff, if you're, for the most part, should be plumbing if you're kind of coming at it at first. And you might want to get into some of the pieces of plumbing at some point, but maybe not. Hypercore is an append-only log, and that is basically the core data structure upon which all other data structures are built, including Hyperdrive and Hyper-B. So when you make a Hyperdrive, it actually uses 2 hypercores. When you make a Hyper-B, it uses 1 hypercore. So Hypercore is just kind of the internal data set, and if you look at the API, it's just like this. You got one function, append, because it's append-only, and that's the only mutation function. And then you got a way to get individual values in the log. Core Store is a sort of utility for managing a lot of hypercores on disk. So, you got 10 different hypercores. You could dump them all into your core store and get them and save them conveniently. That's kind of, how that works. Hyperswarm is our connectivity layer. This is the thing that helps your devices find each other, and it is basically what the Hyperbeam thing is built on, but of course, really everything inside of the Hypercore stack uses Hyperswarm. So this is how, you have some kind of topic like my Hyperswarm D key, and you can announce yourself, your IP address on it, and other people can find your IP address. And Hyperswarm is actually pretty cool because not only does it help you find the IP addresses of who you're trying to connect to, but it includes a protocol for establishing the connection, which in a peer-to-peer context is usually really difficult, something you call hole punching. As far as I know, it is the only distributed system ever created, the only DHT ever created, which does hole punching for you. Usually you have to have some kind of service somewhere, some kind of .com that helps do the hole punching. If you've ever used WebRTC, you know what I'm talking about. Basically, Hyperswarm is a really a fine stand-in for 2 pieces of the WebRTC stack, the signaling, and then I want to say it's, oh gosh, what is the part of the, there's a acronym for the piece, it's not ICE, I don't think, that does the hole punching inside of stun maybe. I think it's stun and turn, which help you do the hole punching. Stun or turn, yeah, turn is, it's ICE for the discovery, it's, I want to say turn for the relays, so I think that's proxying, and then stun for the hole punching. No, stun is tunneling too. Yeah, I don't remember. But anyway, so quality educational content here. So now that's our high level. The app image can work for you. You may have to turn off the sandboxing. That's kind of the problem. Anyway, not getting into that right now. Sorry. I want to stay focused on the topic here. So that's our high level of the stack. So why don't we jump into making an application? Like I said at the beginning of the stream, it's been a while since I I took a vacation for the break, and so I am going to be going off the docs just like anybody would because it's not super fresh in my memory. And what we're going to build is a simple application for exploring a hyperdrive. It's going to be a simple web app. So I'm going to make in my temp directory simple app. I'm going to do an npm init. And so the first thing you're going to do, since we're using the daemon, is you're going to install the daemon, the hype CLI, which I've already done, and it's already running, so no need to do that. We have a way for you to be able to programmatically run the daemon, but I don't need to do that either, because it's already running on my device, so we're just going to skip that. And instead, we're going to jump right here to programmatically connecting to the daemon. So the first thing we're going to want to do is get the hyperspace module. And while that is installing, I'm going to set up my VS Code. I'm going to go to temp and simple app. Okay, and now I'm going to create an index.js. And for the first thing that we're going to do is we're just going to establish a connection to the client. So we'll grab the client API here, and we'll create a new instance. And basically, since there's a daemon running, it's kind of like having a server. And so we need a client to that server to make API calls to it. And so that's what we're going to do with the hyperspace client right here. So we'll instantiate a client object. And there's going to be some async code, so I need to, well, let's see, do I have, do a quick experiment. I'm trying to remember if async await has landed in the version I'm in. 14, probably not. The top level await rather, but let's find out real quick. Yeah, top level await has not landed yet in the node version I'm in, so I'm going to have to lift into a function. Make the font a little bit bigger. All right, let me know if that's big enough for you. All right, so we're going to create a client instance. And so that is going to connect to our daemon, no problem. Just the default daemon that's running, so no parameters needed. And then what we're going to be doing first is just making sure that this thing works. And so I'm going to load up a hyperdrive and read out the contents of it. And I'll use the test hyperdrive that I created earlier. The hyperdrive module comes separately from hyperspace because it actually just kind of builds on top of it. So I need to install that as well. npm i hyperdrive. And then I'll import it. And let's pass in a key to main. And it'll be a string. So what we're going to want to do is instantiate the hyperdrive. And hyperdrive is, in this case, going to take in two parameters. The first one is where data is being stored. And the second one is the key that we're looking to load. Now, since we're using hyperspace, it has its own core store where it manages all the data. And so that's what we're going to pass in, is a instance to the remote core store, right there. And then we're going to pass in the key. And the key needs to be in a binary buffer as opposed to a string. So we're going to do buffer.from keystring hex. And then we'll pass that in. And I'm going to grab the key of the hyperdrive we created earlier. and pass that in. So that'll create our hyperdrive instance there. And then we're going to wait for it to be ready. Now, Hyperdrive's default API is callback space because it was made... Hyperdrive was first made, I want to say, like 3 or 4 years ago, maybe? So normally you would do it like this. But since we're getting with the times, we added a promises layer, which you can access by using the promises sub-object. So now the promises version of the APIs are all available like that, drived up promises. So this is going to, I don't actually think it's strictly necessary in this case. There are some attributes on the drive object that will get populated after the ready event has fired. And so if you wait for ready, you'll be able to log them out. For instance, the discovery key on the drive wouldn't populate until after that. And why don't we confirm that I'm right about that by running this quick test. So if I do this, it should, yeah, null because I didn't wait for ready. Now if I wait for ready, there's that discovery key. So that's what the point of ready is, but we don't need to do that right now because we're just going to call readDear, which, you know, internally it's going to wait for ready, so there's no need for us to wait. And there we go. We just read out the files inside of the hyperdrive. Simple enough. So the API to Hyperdrive, let's see if there's any more sort of, any more that we need to, ooh, that might be wrong. Come back to that later. All this is fine, all this is fine. Yeah, okay. So now if we jump over to the Hyperdrive API reference, it looks more or less like a sort of the Node.js FS interface. So you got things like read file, create write stream, write file, unlink, mkdir, rmdir, etc. And so what we're going to build now is a little localhost web app for clicking around inside of our Hyperdrive. Really simple use case, you know, just to kind of show, you know, the basics of how to use this thing. So to do that, we're going to need to create a Node.js HTTP server. And well, let's see how good my Node API memory is. Okay, so I'm going to pass in a request listener, which would be rec and res.write head to 100.end hello world. And then I'm going to call listen on 8080. Okay. All right. Got our localhost server running. And so what we're going to do is basically treat the localhost as a pass-through to the hyperdrive so that whenever I make a request to anything, the path will get routed to the hyperdrive and load up whatever file or folder is there. And if it's a folder, it's going to list out the files inside of that folder and give links to them so you can navigate around. So we'll start by just doing a simple dump of the files. And I need to make this async. Okay, and there's that dump of the files. So next we need to get some logic in for sort of routing the request to the path to choose what file or folder we ought to be rendering. And now I got to try to remember if the Node.js request, I know it has URL. Does it have a path? A path name? Let's take a look. There's path, and then I'll go ahead and dump the request object as well in case I'm wrong. So let's see. So it's not path. It might be path name. Let's try a couple. This is level when that output is totally useless. Let's try path name. If anybody in the chat remembers what I'm looking for here, I'm pretty sure rec.url is in there. Okay, rec.url is our winner. A little weird, but okay. Rec.url is the path. And so, first thing we need to figure out is what's at the path. So we need to run a stat on the hyperdrive at that path. So we'll call a stat command. And that's going to give us some information about what we are looking at. And here's that stat. Now this is the sort of unhelpful view because what we need to do is interpret the mode to figure out what exactly the object is. And so we use the same as node. Is it a file? Is it a directory? And there we go, and we are looking at a directory. So, when that happens, we now have a branch. If it's a directory, we respond there, and if it's a file, we respond here. So if it's a directory, we'll do a readdir at the path to get the files out. And if it's a file, we'll grab, well, we can grab the content, but actually that's not what we're going to do here. We're going to do it differently. We're going to want to stream the response. And we'll get to that in a second. So for now, we'll just say, give it to do a response. But for the directory, we need to craft a little HTML. And so we'll do that like this. We'll do a template string. Not going to worry about the fact that the spacing is going to be funky on the response. Doc type HTML5 or just doc type HTML? I think it's like that. It doesn't really matter. And then inside that response, we will map through the files. We'll put each one in a div. And then we'll serve that response. Okay, and we did pretty good, except I forgot to call join on the array there. This is why nobody ever builds web apps this way, because this is a terrible way to build web apps, but we're doing it like this. All right, so now we're getting that in HTML, and those each should be wrapped in a div. I'm sure they are. But that's not all we want to do. We also want them to, be links to the individual files. And so it'll be div and then an ahref, and we can actually just do the plain file name as opposed to constructing a URL, because they will come out as regular URLs, or relative URLs rather. Okay, so now they're links. And if you look down, you're not going to be able to see this, but the links look correct in the bottom left, but of course we're getting it to do when we actually click through to them. But you can see the URL is correct right there. So let's add some more information in our hyperdrive real quick so we have more to test against. So I'm going to do mkdir dir1 type drive mkdir. Okay, and dir2. And then inside of dir1, we'll put a file real quick, like hello, and pipe that into dir1/hello.txt. And then I'll restart our app, refresh dir1, there it is, hello. Now, looks like, interesting. Okay, that's interesting. So we ran into a bug right there, and a couple of bugs. Okay, good stuff, good stuff. So the first bug that we ran into there is dir1, the relative path didn't work correctly. Y'all can't see this, but what it's linking to is /hello.txt as opposed to /dir1/hello.txt. And the reason for that is that I don't have a trailing slash. And that's a problem for our relative URL resolution. So let's get a redirect in here. If it's a directory and the path doesn't end in a trailing slash, let's just redirect it to to add the trailing slash. And now we're really going to test my HTML knowledge, or my HTTP knowledge, because let's see if I can remember how to do this using URL codes. I believe it would be 303, and then location path plus the trailing slash. Okay, let's see how this goes. Nailed it. Okay, now when I click on this, it'll work semi-correctly. Didn't quite work. Interesting. Should be seeing to do. Why don't I see to do? Huh, that's interesting. So this, oh, it did a trailing slash on hello.txt. Why does it think hello? Did I do mkdir on hello.txt? Let's see. I did. Hello.txt is actually a directory, so that's not right. Let's rm.dir. And then let's do our command again, but this time it should be put, not mkdir. Okay, now it's, as soon as I start my service again, it's actually a file. Okay. So, making progress. One other thing I'd like to have is if you're not in the top level, there should be the little two dots to let you go up a directory. And that's pretty simple to do. We just take a look. If the path is not the root, then we're going to add the link. One thing I should point out is that you definitely shouldn't do what I'm doing in any real application, which is taking the file listing and just dumping the file names into the HTML unescaped. Depends on what your situation is. If you trust the hyperdrive that you're loading from, not a problem. But if it's like some hyperdrive that any random person could give you, you would actually want to escape these file names before putting them in, because they could be used for HTML injection. But we're not going to worry about that right now. And there's our up directory bit. Okay. So now we have one more task. And that is to actually output the contents of files whenever you visit them. And for this one, we're going to use create read stream. So we'll do a write head of 200. And then we're going to do create read stream on the path. Not create stream, create read stream. And we're just going to pipe that into the response. And as a result, you get the file. Simple as that. And there's our really, really simple hyperdrive exploring application. If we wanted to, we could do this another way. We could make it content equals drive.promises.read file. We could just read the file into memory entirely, and then do res.end content, and the same results will occur. Outputs just as before. The difference is that it's just a little bit, on larger files, less efficient, because you're now loading up, I mean, it's less efficient always, but especially on larger files, this means that you're reading the entire file into memory before sending it out to the browser, and there's really no need to do that. You can just have it so that every time a chunk is read out of the drive, it gets piped directly into the response stream and kind of cleared out of memory immediately. And so that's just a slightly more efficient way to do this particular thing. So there we have our very simple hyperdrive loader. So let's see, how many people? We still got 10 folks in the stream. We could take this to the next level if y'all are interested, and the next level would be getting this thing to handle multiple different kinds of Hypercore data structures. For instance, make it so that it correctly handles when you load up a Hyper-B in addition to a hyperdrive. And what that would entail is detecting what kind of data structure we've landed on, and then changing the behavior of our response handler accordingly. A little bit more work, to be sure, but we could do it. One thing that I didn't, so yeah, I don't know, say in the chat if you'd be interested in that, and if not, I could just switch to sort of general Q&A, or build something else, or show how to do something else. More than happy to do that. One thing that I did not get into with this is basically this application is reading out of the local cache only. It is, so if I were trying to access a hyperdrive that were not in my local cache, I didn't create it or I haven't synced it previously, this application would fail to load it. And to do that, you would need to get the hyperspace to go onto the network for the hyperdrive. And the code example that we had looked a little wrong, so I need to look into what that is. But there's a really simple function you use. If I go to the hyperspace API here, it's just the replicate command on the hyperspace client. So if I call client.replicate, now here's the thing that I'm a little unsure of. If this thing is working the way that it ought to, you ought to be passing in the drive, and that's what makes sense to me. But I think actually that's wrong. It is wrong. You have to pass in an individual hypercore, and that is a little confusing, but I'm going to go ahead and explain what that is. Every hypercore-based data structure is built on hypercores. And really, for now, that you just, this hyperdrive and hyper-B. My chair is falling apart. 1 second. The wheels came off. It's a bad metaphor for my stream. All right, hang on. Okay, hopefully that won't happen again. What was I talking about? Okay, yeah, so you got hypercores that the structures are built on top of. For Hyper-B, there's just the one hypercore. All the data is written onto it. And so in Hyper-B, that hypercore, you can access it as the feed attribute. Wheels, how do they work? Feed, log, it's kind of means the same thing. So if we were doing a Hyper-B, it would be b.feed to get the hypercore, because you need to pass a hypercore into the replicate function. In the case of hyperdrives, it's actually 2 hypercores, and if you're really getting deep into it, it could be more than 2 when mounts get involved, but we don't need to worry about that. But there are 2 hypercores inside of a hyperdrive. There's the metadata one, and then there's the content one. The metadata one is where all of the sort of, well, the metadata is listed, so like the file listing. All the information about like what the file names are, what directories there are. It's actually sort of like those stat objects you saw whenever we do a call stat right here. What it's actually doing is just reading the information, the stat information, directly out of the metadata hypercore. So like the entries are like a collection of those stats structures. And then the content hypercore is where the actual bits that comprise the file are stored. So you have these 2 different hypercores side by side. I imagine a lot of people in the stream already know this, but you know, if you don't. And so the reason that we do this is that this means that you can actually list out all the files in a hyperdrive without having to pull down the drive, the file contents. They're kind of kept separate. So then you look up the content of a folder, you find the file you're looking for, and then you can reference over to the core and pull out just the blocks you need. So it's sort of an efficiency thing. And so that's why in the case of a hyperdrive, the metadata drive is sort of like the identifying hypercore or the root hypercore to the hyperdrive. It's the one that its key is what is used to identify the hyperdrive. And so whenever you're calling replicate, what replicate is doing is it's going on the network and announcing like, hey, I got this thing. I'm looking for people that also have data for it. You know, you're swarming. And then whenever you connect to people, it's going to exchange you know, the bits and all that. So that's what the replicate function is doing, and you're passing in the hypercore that identifies the data structure. In this case, that would be the metadata drive, metadata core on the hyperdrive. So that's what that is. Let me know in the chat if that was in any way unclear. But I got 2 thumbs ups for the Hyper-B stuff. So let's do that. So I think the way I'm going to handle this is I'm going to start by basically putting all this code aside and then building a Hyper-B specific script. And then we can merge them together and make it intelligent enough to correctly detect which structure we're looking at and give the correct handling accordingly. So we're going to create an async serve drive function. Got a question. So the replicate on the content happens automatically. Yes, it does. And it's replicated on what you call on demand. Sometimes we call that sparse replication, which basically means that whenever a peer makes a request, they will only download the files and the pieces of metadata that they need to serve that request. So if I start swarming somebody's drive and only ask for the index.html, that's the only file I will download into my local cache. If you want to download the whole thing, you can command it to download the whole thing, but by default it does not. So, I'm going to create the serve drive function, and I'm just going to move all this code over there. And we'll save that for later. And I'm going to remove the replicate bit. We're just not going to worry about that for now. And I'm going to comment this out. So we're doing Hyper-B now. Same as Hyperdrive, we install the module separately. Oh, you know what we didn't handle, which would probably be smart to handle, is we didn't handle not found, a 404 condition. Why don't we do that real fast? And then we'll get into the Hyper-B. Just this is pretty easy, but you know, still worth doing. So we'll call serve drive function, and it's pretty straightforward. We're just going to wrap this stat in a try catch. Well, let me think. Const is block scoped, is it? Is const block scoped or lexically scoped? Oh, it looks like it is block scoped. Nope. lexically scoped. Okay, that's what I thought. Ugh. Try catches and lexical scoping. There we go. So, rapid try catch, and so like stat will throw if the file doesn't exist. Simple as that. So if that happens, we just do a res.write head 404 and then file not found, and we return. Oh, there we go. File not found. All right, now let's get into the Hyper-B. So, first things first, I'm going to install Hyper-B. So one of the cool things that's happening with this is basically Hyper-B and Hyperdrive. This is a really pretty elegant thing that Andrew and Matthias managed to put together, where Hyper-B and Hyperdrive, really their main dependencies, they need to know where their storage is. But the reason they need to know about the storage is so that they can get access to the hypercores that they're built on top of, right? And they don't care whether or not they're getting the native, hypercore module. So if you're using the individual modules, you could pass in the hypercore directly, or if it is a sort of facsimile of that API, which is what it is in the case of Hyperspace. Like the core store response here, like it's basically in the Hyperspace API, there's this remote hypercore API that looks almost exactly like the normal hypercore, but it's actually talking over a socket to the Hyperspace daemon. And so you can have the remote hypercore or the normal hypercore pass them in, and Hyper-B and Hyperdrive are completely agnostic about where they exist. So in theory, this Hyperspace client could be connecting to, we don't have the mechanics for this quite yet, but it's pretty straightforward that the actual Hyperspace daemon could be running on a different device. And I would just be, setting up the Hyperspace client to connect to that other device and passing in the remote hypercores, and it would work just the same. So that's why you install Hyperdrive and Hyper-B separately from Hyperspace, because Hyperspace doesn't actually, that whole thing doesn't actually know about Hyperdrive or Hyper-B. It's completely agnostic to the high-level data structures built on top of it. So that's why we are installing those modules separately. And so now I'm going to import my Hyper-B here. And I'm going to comment that out for now. And what is my usage for Hyper-B? Like I said, I got to check the docs, same as anybody, because it's been a little bit too long. All right, so yeah, you pass in. Yeah, so this one is slightly different. With Hyperdrive, you pass in the core store itself because it needs to load additional hypercores. It's going to, it has some kind of logic in it for, you tell it which key you want to load, it's going to look up the hypercores as needed. With Hyper-B, you're not actually giving it the core store, you're just giving it the remote hypercore, or the hypercore interface. So in this case, I'm going to be doing client.corestore.get, and then passing it the key. So basically I'm getting the hypercore that the Hyper-B is built on top of, and then I'm passing that hypercore into Hyper-B. So to do this, I need to create a Hyper-B for us. Oh, that's right. Yeah, this is actually a known bug, but it should still work. But that dump, ignore that. Known issue that I need to tackle pretty soon. So Hype-B ls. Okay. So I'm writing a couple of test entries into the Hyper-B. And so what you can see here, I kind of got silent there because, again, don't remember how I wrote this thing, so I had to just try it before I talked. So, like I said, Hyper-B is a sort of level DB-like database, key value store. And so I called two put commands, writing the entries 1 and 2, and giving them the values first entry and second entry. And then when I call an ls inside of it, it's listing out those key values. Pretty straightforward little bit there. So this is going to be our, our Hyper-V for testing. And so let's take the drive key and save it as a constant for later. And then we'll take our B key and pull that out now. Okay, and that should now give us access to the Hyper-V. Now, with a Hyper-V, you can pass in information about the encoding so that it kind of automatically encodes the keys and encodes the values in a way that's useful. I'm trying to remember what I think this is actually the default encoding that we're pushing here. It's not the default encoding if you don't pass anything in, but I'm pushing for us standardizing the encodings across the board for convenience. But anyway, so we'll do binary key encodings and JSON value encodings. Yes, we'll be actually. For the sake of this video, we're just going to use UTF-8 keys. I actually recommend using binary key encodings, and all right, don't worry about it. We'll just do UTF-8 for now. So to make sure that everything is working correctly, we're just going to do a b.list, and the list function actually is a stream, which is a big pain, so we're not going to do a list. We're going to do a get. I have personally mixed feelings about streams. They're kind of a pain. But anyway, so let's just make sure that the get works. Okay, this is something else we need to get around to. Hyper-V does not have the same constructor pattern as Hyperdrive, so we need to fix that. But okay, there we go. So now we just got the value of the item at key 1. And get actually outputs an object, sort of a wrapper object with this metadata about it. Which is sort of interesting because not only do you get the key and the value, but you also get the sequence number, which tells you sort of like what the revision of the write was. So if and when you get into versioning your data sets, that becomes a useful piece of information. So now we have get handled. And so now we need to write our Hyper-V server. And I am going to do a copy and paste here. But, let me think. The mechanics are going to be a little bit different because Hyper-Vs are not like hyperdrives, of course. They don't have a notion of folders versus files. There is a mechanism for doing subdrives that we're sort of in the process of not subdrives, excuse me, sub-databases, similar to LevelDB kind of sub-levels. But that's still in the process of getting standardized. The default stack hasn't quite matured this part of it. So really there is 2 operations that we have at our disposal right now for reading the thing. A list, which is going to list out a range of the data set, and then a get. So there's no stat. So we can't ask okay, are we looking at a container of values, or are we looking at an actual value? So the way I'm going to build this for now, and this is sort of evolving. So take this bit for as a kind of a temporary situation, not as gospel, but this aspect about how the sub databases work, the sub Bs. But for now, we're just going to say if you're looking at the root, just list out everything, and if you're looking at an individual item, just get that. So that means that our logic is slightly different. Rather than is directory, we're just going to see if the path is at root. And then if it's not, it's going to be an individual get. So for the list, let's get over to our API reference. Actually, is all we need. A little cheat sheet. For the list, we're going to do create read stream. And I'm going to do it like this. Await new promise. I'm going to get some stream helpers. I'm going to install concat stream and pump. Because nobody in the world ever wants to just use vanilla vanilla Node.js streams. So I'm going to do pump, and I'm going to do the b.create read stream. I'm not going to pass anything in, just going to get all the entries. And then I'm going to do concat, which should get us all the entries, and then I'll just resolve with that. And then the last parameter of pump is the error handler, which if that happens, we just call reject with the error. Look at all that boilerplate. Yeah, do not personally love streams. Anyway, so there we have entries, and I'm just going to log that out to see what it looks like, and then I'm going to do a res.writehead to 100.end to do, and return. One last thing. We got to call our serve B function. And let's see how we did. Okay, misspelled concat stream. Can't do that. Try again. Okay, so there's that get. Left that in. Let's pull that out. And let's see what happens when I load the root resource. Okay, to do, correct. And there are our entries. And we got a reference error, so I need to fix that. But okay, so exact same kind of output as the get function, just a list of them now. So now let's dump that out onto the page. And notice it includes the values. So unlike read dir, you're actually getting the values. Now where does that drive come into play? Bugging because we had drive in there, line 67. Huh. Oh, you know what? I bet a favicon request is going on in the background. That's probably what that is. Okay, so we got our entries. So now we need a similar thing to this. We just take the HTML. Don't need the double dot up, but we do need entries. And we're going to be using the key. And then we'll do a equals and then the value. And then we'll do sequence equals entry.sec. And let's take a look and see what we got. There we go. There's the listing of our Hyper-V. And now let's just do the get, which is real simple. We just do const entry equals await b.get at the path. Need to wrap that in a try catch so we could handle 404s. And we'll just dump the entry value when we do this. And when you 404, we respond with the entry not found. And it broke right away. Now let's see. It may have a leading slash on the path, and we may need to remove that. It does, so we'll just do a quick little slice. So that'll cause slicing it one character in, that'll cause it to drop the leading slash. There we go, first entry. Can the value be a JSON object? It can. It can be a JSON object, so why don't we get an example of that. So if you want to write JSON into Hyper-V using the hype command line, well, let's write the package.json. So you can't do, we want to use the put command to add it. And you can't just put the JSON in here because there is an escaping nightmare that comes into play where you need the double quotes inside the JSON. And so to get around that, what we'll do is we'll create an our JSON entry, and I'm just going to cat the package.json and pipe it into the put, and that will make it work, and it's intelligent about the fact that, okay, that's JSON. And now I need to start our script again. And there we go. It's JSON encoded. So we need to actually do JSON.stringify on the values. And this will look like holy hell because it's a package.json. So, oh, interesting. What are you doing here? Didn't I just... Oh, I didn't save. Yep, there we go. Yeah, not too bad. And if I click on it, there it goes. Okay, so now we have a Hyper-B quote-unquote browser. Step 2 complete. And now it's time for step 3. Before I move on, does anybody have any questions? So, while I give space for questions to come in, I'll explain what's going to come next. So first of all, you know, I could make it so this thing, how do I want to do this? We could make it so that it reads the key off of the path and all that, but I'm just going to make it so that whenever the thing starts, I choose to pass in the drive key or the B key, and it just adapts accordingly, rather than, you know, because it's really just for an example. And so we're going to have a, we'll just say const is drive, and we'll detect if it's a drive or a Hyper-B, and then we'll just call the logic accordingly after that. So, okay, time for questions. Is there a way to access the keys as files or convert them to files? Mario, I assume you're asking, is there a way to like access the Hyper-B's listing of keys and treat them like files? Now, when you say access them like files, are you meaning like using Fuse, like make it seem like the native file system that the operating system is rendering, or explain a little bit more what you're looking for there. Ryan asks, yes. Okay, so the Fuse interface is actually sort of not maintained at this stage. We kind of put that down, put it aside, said, okay, that was cool, but kind of a kind of a nightmare to get right. And so there for somebody to pick up at some point in the future. But you know, you got cross-platform problems. Windows isn't supported. You get all kinds of weird glitches that come into play between Mac OS versus Linux, et cetera, et cetera, et cetera. So we just kind of put a pause button on that. So there's not currently any Fuse interface written for Hyper-B. The Hyperdrive Fuse interface still works correctly and everything, but we're just not kind of focusing resources on it at the moment. If you were looking to export the key listing as a file, I mean, you could just do use the Hyper-B, the hype command line to do the BLS and then like, you know, dump that into a file or something like that. But there's not currently a way to like do the reverse, to take a dump of the Hyper-B in file form and like hydrate in a Hyper-B. Probably a pretty easy script to write if somebody were inclined. Ryan asks, so it seems like you could almost leverage Hyper-B to be a kind of pub sub if you wanted. Is that reasonable? You need to be able to watch for changes to topics, but I assume that's possible. That's true basically of any Hypercore-based data structure. You can sit and watch any of the Hypercore structures for changes and react to them accordingly. Now, I don't know if Hyperdrive has that implemented. I don't know if Hyper-B does. Let's take a look real quick and see if it has a watch command. But yeah, you could certainly do that. And it's an interesting idea. In fact, one of the things that we so there's no watch command written there. I have to look and see what all is inside of the Hyperdrive's watch command to see how easy or difficult it would be to do over here. I mean, it's definitely doable. I just don't know what kind of boilerplate is required to make it happen. But yeah, one of the things that we think is interesting is exactly what you're talking about, having the sort of data sets be treated almost like a messaging bus, where whenever a change occurs, processes can be sitting and watching those changes and then reacting to them. And once we get multi-writer in, that gets really interesting because you could have multiple different devices all watching the same data set and then doing things like pipelines of transformations. So for instance, here's a trivial example. A service that is designed to watch the markdown files for change, and anytime a markdown file gets changed, it automatically writes the HTML conversion as a .html file next to it. And so you can imagine a whole set of services that sit there and watch Hypercore structures and then sort of as like a distributed pipeline. Yeah, I think that'd be a fascinating thing to do, and we just need to kind of get our infrastructure to that place. But it's one of those things we've been talking about that forever. As like, hey, wouldn't it be cool if? Mario asked, does content deduplication work? So when people ask about content deduplication, they're actually often asking about multiple different things. So there's two different versions of it that I'll answer. The version number one is sort of what you might call universal deduplication, where it's like if there's a file that's shared across multiple different hyperdrives, for instance, and you have all these hyperdrives on your disk, will they all share the same storage so that, let's say, jQuery.js, it's the exact, let's say you have the exact same jQuery.js in 5 different hyperdrives. Are they going to deduplicate between all of them in the internal storage? So the answer to that is no. That is not currently in there. I think there may be some headway towards that in the near future, or maybe distant future, but not there yet. So that's version 1, the kind of universal deduplication. The second one that comes up is deduplication in the history, which is honestly probably not that important of a feature, because what that's sort of getting at is like if you were to write, well, it may not be totally, okay, I'll take that back. Deduplication in the history. So within a single drive, if you write the same file 5 times, does the content of that file get deduplicated? The answer to that is also no. So it's something that's possible, but basically both of those require the system to be sort of producing content hashes of all the files so that it can do the deduplication. There's a little bit of added overhead that comes along with that, but it is a thing that could be doable at some point. Yeah. So yeah, if you save the same file twice, yeah, it'll currently cause it to grow. Now there's a kind of a third related topic, which is just history cache management in general, which is, all Hypercore data structures are versioned, and they retain the history of all the versions in the cache so that you can summon previous versions. It's a nice feature to have the versioning, but it means that the stupid data set is growing on your disk and not clearing out old versions of data that you no longer need. And this is what I'm kind of have been referencing when I talk about fixing some of the kind of the details that we have not gotten around to. We need to have some tooling for being able to say, okay, hold on to that thing in history, but the rest of them, go ahead and clear those out of the cache because you're just accumulating cruft by holding on to those. The good news is that we actually took a step forward on that approach. I do agree, versioning is great. So it's, I'm not, oh gosh, what were we thinking? But it's just a downside that we have to get around to fixing. And we do actually have some headway on that because the first thing that you really need to have the version management is, to have the history management, is to have a good way for sort of identifying versions in the history so that you can then say, hold on to version 1.0, but not anything before that and whatever. And we now have those version tags. So you can actually now mark a specific point in a hyperdrive or Hyper-B. No, actually just Hyperdrive supports this right now. You can mark a specific point in the history with a tag, sort of like git tags, and then have a nice sort of, rather than a random looking number, it can be something like v1.0.0. So once with the tags, we can now do the next step, which is to have some sort of management where we say, keep the data for the following tags, but go ahead and clear out the history for the other tags or untagged files. So small files with small changes win over big files with small changes. 100% correct. Yes, at this stage in the stack, you are much better off breaking up data into small files if possible. So if you're thinking about, for instance, storing a bunch of data in like JSON, don't do one big JSON blob. Break them up into individual JSONs if you can. Okay, so now for the last big step of our app, the data structure detection. I showed this in another stream. I'll show it again. This part is a little bit of an undeveloped part of the stack, considering how common it's going to be needed, and we just haven't quite landed on how we want to address it in a sort of convenient fashion. So I've got some code that I wrote to handle this that's I'm going to be more or less copying and pasting in my own projects until we figure out exactly how to handle this in the long run. And those blings are a little annoying, so why don't I'll just mute my computer. What we need to do is we're going to be handed a key, and we need to figure out whether or not it's a hyperdrive or a Hyper-B. And once we figure that out, we can then load in create the object for the hyperdrive or the Hyper-B accordingly, and load it all up. So I'm going to open up the code from the Hype CLI. And I hope that I don't have anything embarrassing in my work folder. All right. So there's the Hyper CLI, and I'm going to just go right over to the code that we're going to be grabbing. Okay. Well, my computer's chugging a little bit from the streaming. So let me move this over and expand it a little bit. So this is the code from here to here that we are going to be copying out. And I'm going to step through this piece by piece. So the thing we need to do is all Hypercore structures are self-identifying. In the first block that you write to a Hypercore, you put at least in Hyperdrive and Hyper-B, they put a header message, which includes in it the first piece of it is it's a proto-buff encoding, and then the first thing is a string in both of them, and that string identifies what the data structure is. And so that's what we need to do. We need to get that first block out of the Hypercore, parse the protocol buffer, and then read that string that's in the first thing. And there's a cleaner way in theory to do this, according to Matthias tells me, and I just haven't gotten around to it. And before we continue, I have to let the cat out. So let the cat out, and then we can do this. Yeah, you want out, don't you? Okay, so go with the kitty. Okay, so to do this, I need to grab the protobuf data structure code out of two different places here, Hypertry and Hyper-B. So we're getting into some internal details again, and like I said, we really need to kind of clean this up so it's more approachable to people, because this is a pretty common need. Maybe I'll write a module at some point that wraps this. Hypertry is actually a data structure that hyperdrives are built on top of. This is a detail that most people don't need to know. And in fact, we're talking about moving hyperdrive over to be built on top of Hyper-B's, so Hypertry may end up falling out of the entire lexicon. But Hypertry is where the meat of the hyperdrive implementation is, and so it's actually a Hypertry message that we need to grab. Go figure. And so the messages, we call them messages, that's just the reference to what the sort of pieces of information being put into the Hypercore. Each of those entries, we call them messages, those data structures. So we're going to grab the two message encodings, and I'm going to change this over to old school imports. I didn't even realize I was using CommonJS instead of ES modules, because I usually use ES modules. But anyway, so then what we're going to do is for the key, I'm going to copy this code out real fast, move it over to our thing. So the first thing we're going to do is get a hypercore for the key that we're given. And so we're getting this out of a hypercore, just like we did with the Hyper-B. This will give us the Hypercore API, and then we're going to wait till it's ready. Do we need to wait till it's ready? We probably actually don't. We could skip that because we're going to be just doing this right here. We're going to just grab the header block. So block 0 in the Hypercore. And then we're going to first assume this probably could be a hyperdrive, so we'll try decoding it with the hypertry header encoding, right? So we're just calling decode using the hypertry header, and this will throw an error if it's not the correct encoding. So we want to wrap this in a try catch, and if it parses correctly, we're off to a good start. And the type string will actually be hypertry. And so we do if header.type is hypertry. We are looking to find out if it is a hyperdrive. And so if it is a hyperdrive, actually, well, let's do this even more generically. We'll do type. If it's hypertry, then we'll do, yes, we're looking at a hyperdrive. If not, we're going to throw to take us to our next block. And then we're going to parse it again, but this time we'll use the Hyper-B header. So Hyper-B messages, header, decode the header block. And in this one, it calls, instead of calling a type, it says protocol. So if the header.protocol is equal to Hyper-B, then we know the type is a Hyper-B. This could throw as well, so we need to wrap this in a try catch. And if all has failed, then we need to say console.log. I don't know what this hyper is. And then we need to exit the process. Now, we should not hit that because we're controlling what we're passing in, so unlikely. But in your own code, this very well could happen. Now, if it does, you need to handle the error appropriately. You can say something like, I don't support this, and what have you. But okay. So then once that's done, we then just do the appropriate loading code for the structure. So if the type is hyperdrive, we'll load the drive, and if the type is hypercore, or excuse me, Hyper-B, oh brother, we'll load the Hyper-B. And a nice thing is we can actually just pass the core that we loaded earlier. Now I've got some kind of error here. I missed that parenthesis. And then we're just going to start the server depending on which one we got. And there you have it. So that all makes sense. We're creating a hypercore for the given key, pulling out the header block, trying to decode it for each of the different data structures that we're interested in, and checking that the information checks out. And if it does, then we move forward, and if not, we give up. And then we are handling them according to, which data structure it is. So we have the B key getting passed in, so when I start this thing up, we should get the, all right, we got an error already, get client, right, bad copy pasta. So when we run this, we should see the Hyper-B. We do. And so now if I change it to pass in the drive key, it should appropriately detect that and give us the drive interface. And there it goes. There you have it. So if y'all have any questions about anything I just showed, let me know. Like I said, this code is not great. That is not super clear for anybody. Again, given how common needing to detect what data structure you're looking at, because it's the same URL scheme for all of them, this is something that we need to clean up. So if you are hitting on this need and you're like, okay, I don't know how to do this, I would recommend you check out what the Hype client is doing. So it's, I'll show you exactly how to find this code. Hopefully I won't be moving it anytime soon. Hey, kitty cat. So you go to Hypercore Protocol CLI, and it is in lib hyper struct. And this is a kind of wrapper class that I use to sort of encapsulate the many different kinds of data structures and load the correct one, and so on and so forth. So this is, if you are running into this code and need a reference, I would look inside the Hype CLI code base. I will have the most up-to-date solution for this in here. And as soon as we get something that's a little cleaner for people to use, I'll replace this code with that, and hopefully it will be nicely documented in the website, and you won't have to worry about this cruft. Mario asked, how many different types are there? Well, in theory, anybody can build their own type, right? So I can't actually say, but there are two that we focus on from the course team's perspective, and that is the Hyper-B and Hyperdrive. So two. You could argue that Hypercore itself is its own type. You certainly can use the Hypercore just as a log structure, which is not without value. So, two or three, depending on how you look at it. Okay, well, that's, I think, a pretty good stream here. Does anybody have any more questions for me about anything that we went over, about anything regarding Hypercore that I didn't touch on, anything like that? Now that we've hit the end, I'm just going to say to the folks that were bummed about the Linux situation with Beaker, I am super sorry about that. I just, it's a hard problem. The sandboxing, the process level sandbox is really important for a web browser. You want to make sure that you're having as much as strict of a security model as you can get when you're browsing around untrusted sites. And unfortunately, Electron in the process level sandbox has problems whenever you create the Linux distributables. So AppImage, Flatpak, Snap, they all have this problem where it fails to execute with the process level sandbox turned on whenever it is the binary. It works fine whenever you build the code and like run npm start, but if you're using the packaged binary, it doesn't work. And I could fix it by just turning off the process level sandbox, but I ain't gonna do that to y'all because that is not a cool thing to do to people. So yeah, that's the situation there. Anyway, yeah, thank you. Glad y'all came. I hope this was informative and useful and helped get your feet under you about all the stuff that's going on here. Pretty excited about the kind of structure that we're getting set out here. I feel like the Hypercore protocol itself is getting a much more clarity and solid footing than it's had previously, and that's really good. Yeah, excited to see what comes next for all of this. We're still deciding about what to tackle next, and but we have some ideas that we're cooking around, so I'm pretty excited for 2021. Okay, well, I don't think I'm getting any other questions, so I'm going to go ahead and wrap it up, but feel free to okay, here's a question. Mario is asking what are the next steps for Beaker. I talked about this earlier in the stream, so sorry if you're hearing this for a second time, but we decided to basically get Beaker into a solid point for the kind of minimal use case of what it does, which is peer-to-peer websites. And then we decided that the best thing to do is to press the pause button on Beaker and go and develop the core tech more. Hopefully handle things like multi-writer, handle things like key management and backup and things like that. And basically make sure that that part of it is what is moving forward. And also handle things like tooling like the Hype command line, things like that. more broadly, we're looking to make sure that we can get a good foothold with this technology, right? Because part of the challenge that we have to solve as a team that is trying to create something new is we need to get a proper level of funding for the work. And so one of our top priorities is making sure that we're delivering something that really demonstrates the value and is actually giving value to people as soon as possible, so that we can start to have a growing user base and growing interest, and either get the number of Patreons up to the point that we're able to live off of it, or raise funding for a venture. And if we raise funding for a venture, our current thinking right now is that there are enterprise-focused versions of the stack that we can build out that would be something we could charge for. So that kind of like everything is open source, and then we make a sort of like an enterprise version of something that has like high-level admin features or integrations with LDAP or whatever the heck, right? And we sell that to the big companies, and they fund the development of all the technology and the products for the consumers. So that's what we're kind of thinking right now. And so we all love the heck out of Beaker, but like until Beaker has multi-writer for one, the idea of the peer-to-peer websites is a little bit handicapped. And we tried a lot of things over the past year trying to kind of work around that limitation that we just never really liked. And so it's kind of like, okay, well, let's not do something crummy with that. With web platform stuff, you don't want to ship something that is like core to the platform that's meant to be temporary. Because then people are going to be like, building applications that depend on it. And if it's just a bad base layer for the platform, then it's bad for everybody. So we decided to press the pause button on development there, and focus on getting the core stuff into play, and also focus on making simpler applications outside of Beaker that can do things like handling, transferring files between computers more conveniently, like really simple value propositions to people that is using the tech, so that there's something like very simple and useful that the Hypercore Protocol is providing, so that we can then start to grow our user base and possibly get the funds we need to keep development going. So that's the 100% real of what's going on with this. I am a little bit disappointed that we had to press the pause button on Beaker because, obviously, been working on it for a long time. It was quite a difficult decision to do this, but I am completely sure this is the right call, because, we really plumbed the depths of turning Beaker into something that is able to do like social applications, as I've talked about many times, and the quality of our approach at this stage without having the core technology be involved just wasn't a good product. It just wasn't good software. So this is going to, I think, lead to something that people like a lot more and something that can have longevity. So want to be proud of the work, want people to like it. Pretty important. Okay, so I'm going to call that a wrap. Thank you all so much. I'm going to keep doing these whenever I'm feeling it. So keep an eye out, and have a good 2021. Thank you for that suggestion, DD Pixel. I will reduce the latency so I can get more responsive to the chat, because 10 seconds this is not great. So that would definitely, thank you. Appreciate that. But yeah, have a great 2021. Happy New Year, everybody. And we'll see you on the next streams. And I wish you all the best trying to get back into your work life. But hopefully this was a nice way to procrastinate on your journey to getting back into the slog. So have a great one, and I'll see you on the next time. Oh, God. I gotta fix this chair.